Ever wondered what makes a military tank an unstoppable force on the battlefield? These behemoths of warfare are often misunderstood, shrouded in a cloud of mystery and misconception. Many envision tanks as invincible, hulking machines, laying waste to everything in their path. While this isn't entirely untrue, there's so much more to a tank than meets the eye. Tanks are an intricate blend of engineering, strategy, and raw power. These machines, often seen as the embodiment of brute force, are in fact precision instruments, each part carefully designed to serve a specific purpose. From their imposing armor to their complex fire control systems, every element is crucial in ensuring their dominance on the battlefield. But what exactly makes up a tank? What lies beneath that formidable exterior? How does the heart of this mechanical beast, its engine, function? What about its weaponry and ammunition? Join us as we dive into the fascinating world of military tanks and uncover their secrets. First and foremost, the armor, the steel skin that is the first line of defense. It's the protective shell that keeps the crew and machinery safe from harm. Now, you might be thinking of a tank's armor as a simple, thick layer of steel. But in reality, it's a complex, multi-layered system designed with one goal in mind: to protect. Let's delve a little deeper. Traditionally, tank armor was made of rolled, homogeneous steel. This material was effective against the ammunition of the time, but as technology advanced, so did the need for more sophisticated forms of protection. Enter composite and reactive armor. Composite armor is an armor type that combines different materials such as metals, ceramics, and even plastics. This combination is designed to absorb and dissipate the energy of incoming projectiles, reducing the damage they can cause. Different layers have different properties, and they work together to provide comprehensive protection. On the other hand, reactive armor is a more dynamic type of protection. It consists of explosive panels that detonate outward when hit, disrupting the path and energy of the incoming projectile. This outward explosion essentially reacts to the threat, hence the name reactive armor. Modern tanks often employ a combination of these two armor types for maximum protection. The composite armor absorbs and dissipates energy, while the reactive armor actively counters incoming threats. This layered, sophisticated approach to armor design is a testament to the incredible engineering that goes into each and every tank. Of course, the design and placement of the armor are also crucial. The armor is thicker in areas that are more likely to be hit, like the front and sides. It's all part of a meticulously calculated design strategy, where every millimeter of armor is there for a reason. So the armor is not just a hunk of metal, it's a sophisticated shield designed to withstand the toughest of blows. It's a testament to human ingenuity, a blend of science, engineering, and strategy, all working together to protect those inside and ensure the tank can complete its mission. Now let's delve into the heart of the tank, the engine, the power that propels these beasts. The engine is fundamental to a tank's operation. It's not just about moving the tank from point A to point B. It's about providing the power for all the systems within the tank. The engine feeds the electrical systems, the hydraulics, and the air conditioning. Yes, tanks have air conditioning too. Without the engine, our tank is essentially a very well-armored paperweight. There are various types of engines employed in tanks, each with their unique characteristics. Some tanks use gasoline engines, others use diesel, and some even use multi-fuel engines. Gasoline engines are typically lighter and provide higher horsepower, but they consume fuel quickly and can be a fire hazard. Diesel engines are more fuel efficient and safer, but are heavier and produce less horsepower. Multi-fuel engines, as the name suggests, can run on a variety of fuels. This versatility makes them ideal for military use, where supply lines can be unpredictable. The downside? They're complex and expensive to maintain. The choice of engine has a significant impact on a tank's performance. A powerful engine can make a tank fast and agile, able to dodge incoming fire or pursue retreating enemies. But a powerful engine also consumes more fuel, limiting the tank's range and requiring frequent refueling. Then, there's the issue of noise. A roaring engine can give away a tank's position. Some modern tanks use turbine engines, similar to those in jet aircraft. These engines are powerful and relatively quiet, but they're also expensive and consume a lot of fuel. The engine is also a target. If it's hit and disabled, the tank is immobilized. That's why tanks have armor not just on the outside, but around the engine as well. It's a delicate balance between power, protection, and practicality. Without its engine, a tank is nothing more than a stationary bunker. Next, we explore the brain of the tank, the fire control system. This intricate system is the unsung hero of a tank's weaponry and is responsible for controlling and directing the tank's firepower. It's what takes a tank from being a simple machine of war to an advanced and precise piece of military technology. The fire control system is essentially an elaborate network of sensors, computers, and user interfaces. These components work together to ensure that the tank can accurately hit its target, even while moving at high speeds or in challenging conditions. It's a system that's always evolving, with modern tanks incorporating cutting-edge technology to improve accuracy and efficiency. Think of it like this. The fire control system is like the conductor of an orchestra, coordinating all the different instruments to create a harmonious symphony of firepower. It takes information from various sources, such as the tank's speed, the target's distance, and the wind speed, and processes it to calculate the perfect trajectory for the tank's round. One of the key technologies used in a fire control system is a ballistic computer. This device is designed to predict the path of a projectile, taking into account factors like gravity, air resistance, and the rotation of the Earth. It's a marvel of engineering that enables a tank to hit a target several kilometers away with pinpoint accuracy. Another crucial part of the fire control system is the gunner's sight. This is usually equipped with both optical and thermal imaging capabilities, allowing the gunner to spot and track targets in various conditions. Some modern tanks even have automatic target tracking systems, which can lock onto a target and keep it in the crosshairs, even as the tank and the target move. So, while the tank's armor and engine might get a lot of attention, it's the fire control system that truly sets it apart. It's the brains behind the brawn, the technology that turns a heavily armored vehicle into a precise and powerful weapon. The fire control system is what makes a tank a formidable weapon rather than just a heavily armored vehicle. What would a tank be without its firepower? Let's talk about weapons and ammunition. The main weapon of a tank is, of course, its large caliber gun. This formidable piece of machinery is capable of firing a variety of different types of ammunition, each designed for a specific purpose. For instance, there are armor-piercing rounds designed to penetrate the thick steel armor of enemy tanks. These rounds use a dense core, often made of depleted uranium or tungsten, to punch through armor and wreak havoc within. High explosive rounds, on the other hand, are intended for use against softer targets, like buildings or groups of infantry. They explode on impact, creating a powerful shockwave that can cause severe damage. Then there's the anti-personnel rounds, also known as canister rounds, which are essentially a giant shotgun blast. These are used primarily for close-quarters combat, where the tank is at risk of being swarmed by enemy infantry. The process of loading and firing these rounds varies from tank to tank. Some tanks still rely on a human loader who physically picks up each round and loads it into the gun. Others use an autoloader, which is a mechanical system that automatically loads the rounds into the gun. Regardless of the method, the goal is the same: to deliver a round downrange as quickly and accurately as possible. Once the round is loaded, the gunner aims the gun and pulls the trigger. The gun's recoil system absorbs the shock of the firing, preventing it from shaking the tank too much. Finally, it's worth noting that tanks aren't limited to just their main gun. Many also have secondary weapons like machine guns or grenade launchers to deal with threats that aren't worth a main gun round. The weapons and ammunition are the teeth and claws of a tank, delivering devastating blows to the enemy. So, we've taken a deep dive into the workings of a military tank. We started with the armor, the tank's first line of defense, designed to absorb and deflect high-impact blows. Then, we explored the engine, the heart of the tank, providing the raw power needed for these metal beasts to traverse even the most challenging terrains. We moved on to the fire control system, the eyes and brain of the tank, bringing together advanced technology and human judgment to ensure precision in every shot. And finally, we delved into the weapons and ammunition, the teeth and claws of the tank, delivering devastating blows to the enemy lines. Every component, every part of a tank, is a testament to human ingenuity, a blend of science, technology, and strategy. Next time you see a tank, remember, it's not just a machine. It's a marvel of engineering that combines protection, power, precision, and potency.